So hello everybody. I'm right before lunch. I will try to be quick. So I live and work in Czech Republic, and I work in a company called Raynet, and we basically do a CRM system to help your company sell your product better by having a nice overview of like your clients, your potential clients, and so on. So this is us. And so title of my talk is Testing Your Messages Fully, but it probably should have been called Testing Your App Better Using Lists of Messages. And it is the list of messages that are going to be the hero of this talk. So why me and this talk? Well, in Raynet, we have this main product, main branch, and everybody's working on that. And sometimes some company asks us, like, could we have a custom version that maybe doesn't have these buttons, we don't need them, but we could use some other buttons that do some magic stuff for us. And nowadays we don't agree to do it, but in the past we did. And so I am a part of a small team that maintains like a custom version, but there is a small problem. Everybody works on the main product, and it gets better, and it gets refactored, it gets tested, and everything improved. And when we do these changes, these improvements, we didn't like merge them back into the custom version. So as the main product gets better, the custom version gets like older and like less maintained and so on. So some of the time I really feel like the guy on the left. Like I find myself wishing for better tools, wishing for better tests, and that's my motivation. I just wanted to find out what can be done to maybe have more assurance that your app is functioning properly. By the way, I am stealing a lot of this stuff from Cubic, a company called Cubic. They are a testing company using Erlang, and they are like the state-of-the-art. And so I am trying to bring some of what they have already into the Elm world. So my main point is, unit tests are great, fast tests, which generate random data and test that. They are awesome, but let's fast test your update function using lists of messages, because lists of messages are like the history of the user interaction with your site. Like what can they do? I have few examples of what has been done by Cubic and others. So Cubic, uses Erlang, and Erlang is Ericsson language. And so Ericsson is telecommunications company, and so Cubic tested some of their systems, and one of those systems is media proxy, which basically connects people in calls and in video conferences and so on, I think. So if you had to like name it as we do in Elm, it has some messages like add a person, remove the persons, change some config, and so on. So they created a model, a spec, they ran the tests, and they found like, the test program found like 160 messages that broke the app. But nobody would like to, nobody wants to like sift through like 160 messages. So the test program shrinks the data, and so what it finally showed them was like 7 messages that broke the app. And it was something like add a person, add a second person, remove him, add him, remove him, add him, remove him, and then the app crashes. And like if you removed one of those messages, it wouldn't crash. So all of them were important. And so what they found is that like in the remove message handler, there was some kind of like buggy cleanup. So they fixed that, and everything was well. Second example I have is Dropbox. So John Hughes, I hope I said his name correctly. he's this big evangelist of like property-based testing, which we call fast testing and quick check. And so he modeled how Dropbox should behave. And he ran the test on Dropbox and other like OneDrive and whatever, but he mainly tested Dropbox. And he found, among other bugs, that let's say you have Elise and Bob. So Bob creates a file, writes B to it, because Bob, and Elise synchronizes the file, like gets the file, writes A to it, because Elise, and then nothing happens. Like Bob doesn't get the changed file. So that's a bug. And what they found is that the dirty flag for the file, like whether it changed, it is only set, or was only set in the buggy Dropbox version, when file length changes or file modification time changes. So Elise was so quick that she wrote to the file in the same second that Bob wrote to the file. So Dropbox was like, okay, we really don't think this happened in real life, but we'll fix it anyway. So thank you. And so this is the second example. Third example and last one is Google's Leveldb, which is like key value store, like database. And it's written in C, so somebody, again, like created a model for that in Erlang, ran the tests, and he found like 17 messages that basically, if you deleted a key, it could be found again, which shouldn't be possible. So, you know, he sent the Google team, he created an issue or bug report, and he showed them these 17 messages, they fixed it, and what do you think he did? He just bloop, ran the test again, and it found 33 messages that create the same bug. So then Google fixed it, and it was finally fixed for good. So what I want to say with this is, you know, generating random lists of messages can give you like unexpected bugs, like non-trivial bugs that you wouldn't have thought about if you wanted to test it manually. At least I wouldn't have. Like maybe there is some QA genius that would have, but not me. So I want the computer to do that. So I created some code, and I have a nice story for this. I have a code here, but also Richard Feldman started doing something like this like 2 weeks ago. I was like, oh no, like everybody's going to use his you know, repo. So his is very simple. Mine is, I don't know if advanced or overcomplicated. You be the judge. But I'm going to talk about my one. So, so let's say we have vending machine. So everybody knows vending machine, I guess. So, you know, it holds, in its model, it could hold something like how much does the product cost, how much money you put in, and whether the product is vended or not. And, you know, what could be the messages? So it could be something like, add some coins in, cancel if you find out you don't have enough money, try to buy the product, or take the product, take the money. So basic user interaction, basic list of messages could be something like this. So it costs like quarter of, I don't know what, $1. So you put in some coins, you buy, you take the product, you're happy. It could be something like this. So you add coins, and then you find out that you don't have enough money, so you cancel and take the coins. But really, it's vending machines we are talking about, so it probably is something like this. So, okay, so I wrote a library for this. It's basically a wrapper around like what Elm Test already does. So I have like 4 categories of tests in my head that are useful for this kind of testing. The first one is message test. So here's an example of a test. And, okay, so you give it your model, update, message fuzzer, which means way of randomly generating some message. And then a specific message. Right here, it's cancel fuzzer. And then it starts with your starting model, initial model. It generates some messages. applies them to it. You have the model before message, so it's right after this step. Then it generates your specific message you want to test, and then there's the final model. So usually you are testing that right here. Final model, current coins should equal 0. So canceling should give you all your money back. There is second type of testing, second type of test, which is the same but with some precondition. So if I want to test that buying or pressing the buy button gives you the product, if you put in enough money, it wouldn't make sense to test it when I haven't put enough money. So the test only runs if the current coins equals or is greater than the product price. So basically, message test with precondition is the same as message test, but only runs when something is true. Then there's invariance test, which means no matter the messages, no matter what the messages you generate, something should be true. So it would be nice if the price of the product would be the same. So if you put in like quarter, it shouldn't like give you unlimited like Coca-Colas or something. So again, the signature of the function is a little bit different because you don't have the specific message you want to test. You just like say, give me some messages and this should be true no matter what. So product price should be equal to the product price before the messages. And then fourth type of tests is actually Max Goldstein, who contributes to Elm Test a lot, and I think he maintains it along with Richard. He set my mind on it. I don't think he's the first one who thought about it, but he's the first one I heard it from. So it's called Orthogonality Test, which is a fancy word, but it basically means, no other message than this one should do something, should change this field of the model. So in this test, I am saying only the add coins message should add coins. So if I press cancel 5 times, it shouldn't give me like $1 of like cash. And it doesn't have its own function. It's basically just message test, but you don't give it like the add message. You give it all message except add. And so, yeah, we are testing that current coins doesn't increase with any message except add. So this is kind of the API of the library, and in an ideal world, you would just use it. You would give it like init model, update function, message fuzzer, and the test, and you would be fine. But in Elm, fuzzers are a bit, I don't want to say dumb, but simple. For example, the integer fuzzer, it just tries numbers from -30 to 30 more often. Sometimes it tries zeros, and otherwise it's all over the map. So otherwise all integers go, and it doesn't like do anything intelligently, like to try. Okay, something happened after I put in like 5 coins, so let's try that again and like modify that. It doesn't try. It just like it is very simple. So you have to help it a bit, and you have to restrict those tests. So that basically means move the tested model and the tested messages closer to what you want to test. As an example, World of Warcraft or RuneScape or some other game like this, like there is, you have this, what's it called? Account? No, avatar. And so you start with level 1 player, that could be the init model. But let's say the developer has created like level 80 weapon. You can't just expect in the test to give it like level 1 player and generate random messages and to expect that would test the level 80 weapon, because he couldn't even equip it. So you have to get a bit closer. You could, like, you would never get from the level 1 down there to level 80 somewhere up. So what you could do, what you maybe should do, is start somewhere else. So start not at level 1 player, but maybe generate random players. But in this case, you should really start like with level 80 player that somehow has the weapon in his inventory and can do something with it. So you can fuzz the models, you can choose model from a list, but nothing stops you from just giving it like constant level 80 player. And so that's moving in with the model, but you should also move in with the messages. So I would expect that in a game like World of Warcraft, if you did it in Elm, there would be like a lot of messages. But like really, like I don't know what Richard would do like with organizing the code, but it would be something to see. So if you want to test, I don't know, like using the weapon, like slashing it and whatever, you should really prefer messages that do it. You know, like what's the use of the test if like you have the weapon in your hand and you want to test the slashing, but instead all the messages are like walking around and talking to NPCs and like doing like useless stuff. So Elm test has this nice frequency function that lets you specify the probability that fuzzer will be chosen. So you can say like, I don't know, like 80 times out of 100 just use like some of those messages that do something with the weapon, and otherwise you can like walk around and something. So again, recap, you should test your update function, fast test your update function with lists of messages, with random lists of messages. Because like in other languages, maybe like Java or something, you would have really bad time trying to even like getting your head around like messages and so on. But in Elm, we have amazing Elm architecture. We have like this separation of concerns. So why don't we use it? So just generate random lists of messages and use them on the update and see what happens. Like see what breaks the app, and then help the test a bit. Restrict those tests. Get them closer to what you want to test. So that's it. I hope it helps you find the bugs faster. Thank you.
Any questions? Did you explore sort of generating messages based on the history of messages already generated? I'm thinking of sort of state machine
Sure.
kind of situations where some messages only really become relevant.
Mm-hmm. This is basically the way Erlang does this stuff. And in Elm world, it would mean that the fuzzer for the messages depends on either the model or the list of messages. I have tried it. It would really make sense in some cases. I have in the repo, I have examples folder, and like one of those examples would really benefit from that. Like delete message would only generate with the IDs of like posts that already exist and not non-existing ones. I have tried it. I have it in a branch, but it right now it behaves weirdly. Like when it finds a failure, it never stops running. So there's something weird with shrinking. So there's a lot of like fuzz and then like chained together. So it doesn't work for me right now, but I'm looking at it and I'll see what can be done about it. So yes, that's more general. That lets you test stuff better, but it's still in flux and in development. So we'll see about it. Yeah.
Thank you.
You talked about needing to select the messages at a sort of second stage, but presumably you have to do that right from the outset because you can't enumerate the message union type. So you'd actually have to choose which messages you pass in. Or am I misunderstanding something?
Well, there's like two sets of messages. Like at first, you just generate whatever message, like random. You don't restrict it. But then, like with the message test, you are only concerned about like whether a cancel message does something. So that's the more restricted type of message. So at the first phase, you don't really, at least the way I thought about it, it doesn't make sense really to limit it in any way. You just generate random stuff, and that gives you random model, basically, to which the user can get by clicking around. And then you test your message that the test is really about. Does that help? Let's talk after the talk, yeah.
Please, thank you, Martin.